Okay, so I've got a big sheet of paper here and I've taped it down. I know kind of where I want to draw my Jenga tower. It's going to be somewhere here in the middle of the page. So what I'm going to do is when I set this drawing up, I'm going to draw my eye line really high up, 1 inch from the top probably. So, and I'm going to be really careful to measure 1 inch down. I want to keep my lines as perfectly vertical and as horizontal as possible. When we start drawing bigger, more complicated things, keeping your lines perfectly vertical and horizontal becomes a bit of a challenge. So taking our time, you'll notice I have a really sharp pencil, but I'm going to be precise because it's going to make it easier to take measurements, okay? So this that I just put on here, this is my eye level, and I'm going to extend it pretty far off the page to my right today. I've kind of planned this out in my head a little bit. Okay, so and I'm gonna keep notating these. You really need to be thoughtful and understand these process. So this line I just put in is my eye level, and so I'm gonna write it down as EL. This is my eye level. At this point, you probably know that, but I'm gonna keep using these terms so they become more. So yeah, so this is portrait. If I turned it sideways, it'd be landscape. We're doing portrait today. Good question. Okay, the next thing I got to do is put in my line of sight where I'm standing to view this scene. And because I'm going to draw the Jenga cube over here, I'm going to move my line of sight almost all the way over to the edge of my page. So probably like 1 inch from the edge. And then right up here on my eye level, I could do it on the top of the page too, but I have a piece of tape in the way. But I'm going to measure exactly 1 inch over so I can make sure that this is perfectly horizontal. Hey.
Yo.
Did you need something?
Just if you're like teaching a class, I don't actually need anything. Hey, Jackson, what do you need? I just need like do you have like a pole I could use?
A pole.
Like literally like a pole.
I do not. I'm sorry. Not that I know of. They have a broom down in the ceramics room.
I could probably. Got it. Thanks. Bye, Jackson.
And there's our first interruption for our recording. Okay. But I have a mark here, 1 inch and 1 inch. Okay. So again, to set this up, I actually got some visual. I ordered a bunch of these blocks to help us explain what we're doing here. So up here, if this was right at eye level, so here's our line of sight, here's our eye level. A square looks like, a cube looks like a square, right? But as we move it down, you start to see more and more and more and more of the top until you get down to the station point, and then it looks like a square again, but this time you see the top of it. Does that make sense? Okay. As we move over to the side, so if I move back up something like this, as I move to the side of my eye line of sight, I start to see the edge like this, right? Okay, so I want to do my Jenga tower so that I can see the top and the sides. So that's the top, this is the side. So I want to draw it over in here. Okay, and to give myself the most possible space, I'm going to put my station point really low down here at the bottom of the page. And I'll draw in my cone of vision. So this is the 30, 60, 90 degree triangle. And the reason why we draw the cone of vision is because it makes or it allows our drawing to be less distorted. If you stay inside the cone of vision, it's going to look better than if it's outside the cone of vision. You can draw anywhere and the rules still work, but it starts to look really wonky as you get really far out. In fact, that's actually one of the limitations of 1-point perspective. Because if you notice with my cube up here, the more I move over to the side, the less this is actually a perfect square anymore, the front. It actually becomes another perspective, and that's what we'll deal with in 2-point perspective. But it gets distorted, so it looks really weird when you draw in 1-point perspective really far outside the cone of vision. But anyway, we're going to put in the cone of vision as a guide. It's a really light line. We don't need this in the final drawing, but it helps us make some decisions while we're drawing. It's a tool. Okay. So everything inside of this square is going to look more normal than what will be outside it. That's just how perspective works. Okay. So I need to switch now because I got to find our measuring point. We're going to need a measuring point. And so for that one, we're going to use the triangle that looks like this, that has a 45 degree. And just to let me explain this again, I know I've explained it a few times, but as this cube, the top of the cube gets really, really flat right here, right? And then as it comes down and down and down and down and down until you hit the station point, now we can see the top of the cube. And every line that moves away from us, the 90 degrees, goes to this vanishing point, right? So basically any square we draw in this plane in relationship to us is like this. And so the measuring point, if I drew a line right up the middle, that would be 90 degrees, and that still goes to that vanishing point. But this 45 degree line that I drew here, this is exactly 45 degree lines. That creates a new vanishing point somewhere out here. And that's for all 45 degree lines. Weston. This is every light turned off but 2. Do me a favor. Do you see that cord? Let's just close that window. That cord hanging down right there. If you pull one side, it'll bring down a blind. Does that help? Okay. I think we have one over here too if you guys decide that light's too much. Mac. The first line for the cone of vision is 30 degrees. The second line we're going to do is 45 degrees. So, and I'll write that in. This is 30 degrees. And this is the COV. This is the station point.
And is this station point an inch up from the bottom?
I just drew it in a random spot. The further you put it down, it's like you stepping back to see better, right? The further up you come with the station point, the closer you get and the more distorted things become. And we can show you this with a camera sometime. Would that be helpful? Do you guys understand what the cone of vision does? Ish. Okay. Because we can take a second and I can explain that better if you want. The second thing we need, again, is that 45 degree vanishing point. And so this is a 45 degree angle. That's what I've drawn on here. Okay. And that becomes really useful because a 45 degree angle helps us find the back of a square in perspective. So we're going to put it up here. I'll start it with this, but what we need to know is where does this line intersect with our vanishing point? And so I'm going to have to extend it because I've drawn it really far down. Okay, and where that intersects, I'm going to put a little dot, and I'm going to put MP by it. That stands for measuring point. So that's a 45-degree angle, whereas this measuring point or vanishing point up here measures 90 degrees. Okay. Now, if you guys remember from last time when we were drawing the Rubik's Cube, if you draw it really close to the line of sight like this, you really don't see much of this edge. It gets really confusing and hard to draw. So I want to draw my cube a little further away. Same with the top. If it's right up here next to the top, you don't see very much of the top. So we want to bring it down a little bit and to the side a little bit so we see plenty of the top and the side. So even outside of the cone of vision a little bit, I want to give myself space so that I don't get really cramped on that edge, because that gets really tricky. Okay, so far this should all be a review, pretty much, right? Are there any questions that have come up? Ben, how you feeling? Doing all right? Okay. So the next thing that I got to put in is the ground measuring line, which is the line where we're going to draw basically the bottom line of our cube. Whatever this line is, we're going to put that in. And so I can put it in anywhere I want. It's the starting point. I just know I'm going to make probably like 10 rows. So I'm going to put it pretty low down on the page, maybe down in here. And I'm going to push it. I'm going to put it outside of my cone of vision. And I want it to be perfectly horizontal, so I'm using my square to make sure that it's perfectly horizontal. If I put my square right on my line of sight, that gives me a perfectly horizontal line. But I'm going to put it out here somewhere. Okay. Doesn't really matter where, but I want it to be further away and have plenty of space to draw up in here. And now I can decide how I want to measure this out. Centimeters are pretty easy to measure. And a Jenga tower, it's 3 blocks, right? And they're just longer. And so I got to divide this into my 3 blocks. And so what really matters is that they're the same, right? And so I can use centimeters. I'm going to start somewhere a little bit further. Again, I want some space, but maybe I'll do these 2 centimeters. So I put a mark at 0, at 2, at 4, and then at 6. And that gives me 3 columns for my Jenga tower, right? And then I can lighten up this line. I don't need this line anymore. And we have a couple of options what to do next. So in 1-point perspective, the way 1-point perspective works is we say that one of these faces of the cube isn't actually affected by perspective at all. Like if there was a grid on this, it would appear as a perfectly measured grid. It wouldn't get distorted by the perspective. So I put these centimeters on my ground measuring line. I did 2. So I did it at 2, at 4, and at 6. And that gives me 3 equally spaced columns. Okay, good question. Thank you. So anyway, with 1-point perspective, we say there's no distortion on this. So I could draw my Jenga tower on the front view right now because we know exactly where it's going to be. And that might be a little less confusing than what we've done before. So I've got to put some vertical lines to these, right? So I'm going to draw the front face. And the best way to do that would be if I had a really long square, but I don't think any of my squares... Oh, actually this one might be. but you guys don't have a really big square. So we can measure. So my first line is at 2 inches, and that's 3/4 of an inch. So I could come up here on my eye level and put a dot at 2 3/4. And so that way it's the exact same as that. And then I could draw that in. And that line should be perfectly vertical. But we need the walls of our tower to be perfectly straight up and down. I don't know how tall my tower is yet, but I know that this is, that line I just drew is this corner right here. So that's what this line is. And now I got to draw this line, and then we're going to divide it into 3. And I actually can just measure those because they're exactly the same, right? So we did 2 centimeters. So I can come over here. And put a mark at 2 centimeters. Oh, yeah, 2 centimeters, 2 more centimeters, and 2 more centimeters. And again, I'm drawing this line pretty light because I don't know how tall my tower is going to be yet. I'm going to have to measure that in a second. But I know it's going to end here, and then I know we're going to have 3 rows. I worked for a lot of years in cabinetry. Not a lot of years. I worked for a year in college and then a year after college in cabinetry. But you get pretty good at finding right angles and being precise with your lines so you can cut wood. But does that make sense? This is my front of my Jenga tower. You got that okay, Weston? Okay. So now what we need to do is figure out my rows. Okay. And we're just going to pretend that Jenga towers have squares. I think they're actually like compressed a little bit. They're not perfect squares. But just to make the measuring easy. So with the front, I don't have to, there's a few ways I could figure this out, right? So we could use our knowledge of angles, and I could put a 45-degree angle from this corner up. And I could draw that. And where that crosses there would be the first row and the second row and the third row. You could do that theoretically, and that would give you the heights. But we can also just measure it, right? So we can get our centimeters here and just measure 2 centimeters, 4 centimeters, 6 centimeters. We're going to do 10 rows for our Jenga tower. So I have 1, 2, 3, 4, 5, 6. And then I need to do 4 more. So there's 1, 2, 3, 4.
How many dots?
So we want 10 layers, like a Jenga tower.
10 dots.
It'll actually be 11 dots if you count the bottom dot, right? Because it's the space in between the dots that we're counting. So this is 1 row, this is 2, 3, 4, right?
How much space between each?
I did the exact same as we did on the bottom. So I did 2 centimeters on the bottom, so I did 2 centimeters on the side as well. So it'll end up with squares. Does that make sense, Mac? It actually doesn't matter if you change it as long as you're consistent. So, and then I can start extending those over. So again, with horizontal lines, and you can look and see, look at that mark that I put here. It actually is pretty dang close. right there. I was just a touch off, but not too bad. Thanks for helping each other too, but feel free to ask questions, and I'm just trying to be really precise, keeping these perfectly horizontal by using my right angle here. So this is pretty tedious, right? It's just pretty mechanical. It'll get more challenging really fast. And that is the top. Okay, so this is the front of my Jenga tower. So I know I can erase these lines now, get them out of the way. Again, sharp pencils are really helpful. There are pencil sharpeners in the back if you need to stop and sharpen a pencil. Really dull pencils are hard to get the precision. Okay, so now we want to put this into perspective. This is where the magic happens. We make this 3D, right? And so the first thing that I'm going to do, we could do it a few different ways. We could do it from the top or from the bottom. Let's try from the top just to mix it up. With the Rubik's Cube, we drew the bottom of our square first, but we can do the top, and that'll work too. So I'm going to push the corners back to my vanishing point. These are the orthogonal lines. And I want to be really careful, checking every time to make sure that this stays right on the vanishing point and this goes right to the corner. Even a little bit off can lead to big issues. I'm not going to draw these lines from the sides yet because I don't know if they're going this way or this way with the Jenga pattern. We'll have to figure that out later. But what I can figure out right away is I can find where the back edge of my tower is going to be. And to do that, I'm going to use my measuring point. I'm going to cross the tower right there. Extend this line very lightly back. And where that hits, that's what we just drew. Where's my block with the line on it? There we go. So what I just drew, and it's very light, is this line right here. Does that make sense? Only in perspective. Can you see that even at all? But I figured out where the back edge is by figuring out where this line is. And so it hit right there. And that's the back edge of my box. And so now I can get this. I'm going to be very careful, line it up as best I can. And extend that over. And that's the back of my tower right there. And then using the logic of perspective, I can put in this back line as well. Because now I know where the back corner is, I can bring that line straight down.
Wait,
How did I figure out that one?
Yeah.
Okay. So I'm going to explain the logic again and why it works. But right at the beginning of the drawing, we put in this line right here, right? So once you move away from the station point and into the image, this line always, always, always still goes to the same spot, right? And so when you get up here to the top of the tower, we put that line in, and that shows us where the back edge. There's a line that goes from this corner to the 45-degree measuring point, and where it hits the box, that's the back corner, right? And so I just go over to my measuring point. I hit this corner, and right where it crosses that edge, that's the back. And so then I just have to make every line in perspective is either horizontal, vertical, or it goes to the vanishing point. So I just come in and put a straight horizontal line from that dot across, and that's the back. Weston.
Should the 45-degree angle line, should that hit a point or?
Yeah, so it hit a point on my eye level right here. This is the measuring point. But in perspective, it's really crazy how it works. I don't know how they figured this out, but any degree that moves away from us goes to this line right here, right? So this line goes there, this line goes there. Any degree that is 45 degrees angles away from us goes to there. And those lines continue to point to that vanishing point all the way everywhere in that world. Like it always, every 45-degree angle in this world goes to that line, and every 90-degree angle in this world goes to that line. But that's what this was right here. And now we can just use logic because it has to follow the rules, right? So I have to be able to draw, I can draw a vertical line from here, and I'm going to use my eye level and a triangle to figure it out real quick. But where that hits that corner and comes straight down, that's the back wall of my Jenga tower, right? And then to find the bottom, we have to use our vanishing point again. Oh, gotta use the ruler. So then I just have to connect this corner here, slide that out just a teeny bit. But that's the bottom edge. And if you wanted to check and see, did we really get that right? We could use a measuring point for the bottom as well. We can go from this point to our measuring point. And see where it intersects a line that moves from this corner to that vanishing point. A little bit off. Sure enough, does that point and that point line up vertically? Pretty dang close. So you can kind of, most of the things that we do in perspective, you can solve in more than one way. So I solved this corner by dropping it down, and I solved that corner by using a measuring line, and it still works.